The Honors Pre-Calculus Final Exam Review. This will be question number 13. Number 13 says, find the exact value without using a calculator. So when we see a trigonometric function, and the key word here is exact, so even if we had a calculator, our calculator would not help us because it would tell us a decimal, and a decimal is never exact for one of these trig functions because these are actually irrational numbers. So we need to come up with something that's going to have a square root in it, something with a radical in it. So we need to find this without using a calculator where we're finding a trig function of an exact value. What we need to be thinking of is the unit circle. So one important thing is we have to have the entire unit circle memorized. We need to know that for the final exam. You have to have that memorized for the final exam. You also have to have that unit circle memorized for your calculus class next year. So we're going to do this using our knowledge of the unit circle. So we're asked to find the secant of negative 3 pi over 4. That's secant of negative 3 pi over 4. So the first thing we have to know is what secant is. Secant is 1 over cosine, so this is going to be 1 over cosine of negative 3 pi over 4. Now I need to know what the cosine of negative 3 pi over 4 is, and that's why I need to know my unit circle. So I'm going to draw the unit circle. One of the things that makes this problem tricky is that we have a negative angle. Well, let's go ahead and label our unit circle 0, pi over 2, pi, 3 pi over 2, and 2 pi is coterminal with 0. So now we're going to say, all right, I need to know where negative 3 pi over 4 is. An easy way to start with that is let's say where positive 3 pi over 4 is first. Here's pi over 2, here's pi. 3 pi over 4 is like 3/4, so it's in between 1/2 and 1. This is 1/2, this is 1, this is 3/4, it's in between. So 3 pi over 4 is like 3/4, it's right there. So if we went in the positive direction, that angle that I've marked here is positive 3 pi over 4. But of course we want negative 3 pi over 4. So what we're going to say is just we go the same angle, but we go in the opposite direction. So we go this way, the negative direction, and so we're going to find our negative 3 pi over 4 down here. Another way that we can get this angle besides looking at the distance that we go is we can find the positive angle and then just reflect over the x-axis. So no matter what your negative angle is, if you find the positive angle and reflect over the x-axis, that's going to give you your negative angle. Now that we know where negative 3 pi over 4 is, our next job is to know what the coordinates of this point are. And that's where our memorization comes in, that we know and understand this unit circle well enough to know, usually I only really consider the positive quadrant, the first quadrant, and I know that the point where the two are equal, the 45-degree angle, that's positive square root 2 over 2, square root 2 over 2. So since this is a reflection over the origin, this point down here must be negative square root 2 over 2, negative square root 2 over 2. So now I know the coordinates of that point. The next thing I need to know is that since I want cosine, I need to know that cosine is the x-coordinate, not the y-coordinate. Although in this case it wouldn't matter because they're the same, but often these two are going to be different. So I need to know cosine is the x-coordinate. Now I'm going to take that x-coordinate and I'm going to put it up here, where our cosine of negative 3 pi over 4 is. So we're going to say this equals 1 over negative square root 2 over 2, negative square root 2 over 2. All right, now my next job is I can't leave this like this. I have a compound fraction with a radical in it. We've got to simplify it. So the long way to simplify this is to say I have a numerator and my denominator has a fraction in it. So I'm going to invert the denominator and multiply. So I'm going to take that 1. I'm going to take this denominator and invert it. So I'm going to have times square root 2 over 2. And I'm going to keep that negative sign there. So negative square root 2 over 2. I forgot to invert it. So actually, it is 1 times negative 2 over square root 2. So now I've inverted that fraction, which I forgot to do. And then if I multiply these together, this is just negative 2 over square root 2. Of course, I'm not done yet because I have a square root in the denominator, so I need to rationalize that denominator by multiplying the top and bottom by square root 2. And when I do that, then in my numerator, negative 2 times square root 2 is just negative 2 square root 2. I'm just really keeping the negative out front of the whole fraction. square root 2 times square root 2. You can just say it's just 2, or you can say it's square root 4 and then reduce it later. I'm just going to say it's 2. And then, of course, we can reduce the 2's because everything's multiplied, nothing is added. So I'm able to just reduce those 2's, and now I don't have a denominator anymore, so my answer is just negative square root 2. So now I said that to get from here to here, the long way was to take the denominator and flip it over and multiply. A sort of shortcut is anytime I have 1 over a fraction, I can just take that denominator and flip it over. So I could have directly just gone from 1 over negative square root 2 over 2 and said, if I have 1 over a fraction, I'm just going to invert that bottom fraction. I'm just going to do a reciprocal. So I could have just done that directly instead of going through this step, which I had trouble with anyway. All right, so that is our final answer here. You would, of course, from here go and do this simplification. And that's how we do secant of negative 3 pi over 4. And number 14 is going to go the same way. It's just sine of 3 pi over 4, so you'll have to look at where that is in the unit circle, and that's all we do for that one.